Join us as we guide you through the creation of a simple yet robust Azure Virtual Network module using Bicep. We will start with Microsoft documentations using sample codes and enhance them step by step for optimal reusability and efficiency. So, the first rule of efficient development is never start from a blank slate. All right. Microsoft has a lot of sample bicep code out there. We can look for the one for a virtual network and try to refactor this, properly modify this, and make use of this as a solid foundation for our modules. Okay, we'll begin by navigating the internet, searching for virtual network biceps code, and we go through the quick start templates, and further, we factor this code. Looking at this simple code, we can see it creates a virtual network and two subnets. All right. We can as well see that the values here for the address prefix is hard coded for both the virtual network and the subnet, right? This code works, but everything is hard coded with variables. We will walk through how to turn this into a properly reusable module. This will just serve as a practical step and ways to properly modularize our code. All right, so let's dive right into it, explaining all the details step by step and make this a reusable module. Step one is replace variables with parameters. The first crucial step in creating reusable module is to identify any values that might change between deployments and convert these values into parameters. This allows for dynamic configuration without altering the core module logic. As you convert variables to parameters, consider also providing sensible default values. This approach offers flexibility, allowing users to override default values when necessary, but maintaining the ease of use for standard deployments. The initial sample rigidly enforces the creation of exactly two subnets, right? But in reality, a reusable module needs to be able to adapt to different scenarios. Might be one, might be two, might be 10, depending on the particular scenario. Instead of fixed resource, let's leverage bicep looping capacities with array parameters for subnets. By accepting an array of subnet definition, your module can now provision any number of subnets from one to many based on customers' requirements. This is a great way to enhance the module versatility. All right. Let's look at how clean this is. One loop creates all the subnets dynamically, and notice the output. You use the index I to map each subnet ID back to the original input order. This simple change transforms your module from a rigid into a versatile building block that works for many scenarios. Development environment with one subnet, production environment with many, and anything between. It doesn't matter. It is flexible, it is modularized, it is reusable. Having many individual parameters can quickly become untidy and reduce readability. To streamline our module further, we can group related parameters into a single object. In our example, instead of having like multiple parameters for VNet name, address space, and subnet, we can use a single object, network config, for all the parameters with only the location parameter not included in this, which will get injected at deployment. This significantly cleans up the parameter declaration, and improves the overall organization of our Bicep code. With a group parameter in mind, let's decide how our object would look like. This is what the caller will provide. Now let's break it down how we can reference each layer. This object has three top level properties: name, address prefix, and subnet. We'll see that the name and address prefix are strings, which are just piece of text, but the subject is an array which acts like a list. To navigate the properties, we use the index 0 to access the first subnet and then use dots to get its specific properties. Following the same pattern, we use index 1 to reach the second subnet and pull its data. The completed Bicep module, vnet module.bicep, now stand as a highly reusable and flexible asset. It encapsulates the core logic for virtual network deployment, allowing for customization through its well-defined parameters. The output provide essential resource IDs, enabling seamless integration with other Bicep modules or deployments. So to use our module, we'll write another Bicep template which will be calling the module. All right. We'll use the keyword like we talked about before, module, and we have the name of the module. We just have like vnet, then we call the parts of the module related to the color module. All right. So observe the elegancy and simplicity when consuming our newly created module. Of course, we provide the parameters required in the module from the keywords, the string params. We reference the name of the parameter, which will be our network config, and we have the individual values inside of there. So we can as well, you see that here we're having three subnets, so we have three outputs as well. Yeah, so this is a way of using the module. So let's quickly look at a more practical approach, a demo of this in practice, and see how this goes.